Algebra 2, Chapter 16, Section 2, Matrix Multiplication. An M by N matrix and an N by P matrix can be multiplied. The resulting matrix is an M by P matrix. So these numbers have to match for the two matrices to be multipliable, and the result will be an M by P matrix. If the matrix C equals the matrix A times the matrix B, each element in C is the sum of the product of the ith row. So if you imagine A and B, we take the ith row, whatever that happens to be, and the jth column, and we multiply each entry in the row and column by each other, and then we add those up, and that is how we get each entry in the result matrix. So you can see there's going to be a lot of arithmetic to do this kind of multiplication. So formally we can write C sub ij, so the ith, jth, and the I in row, j in column. Remember, it's always row, column. Goodness, I did that backwards. The rows go up and down. Row, column. So we go row, column. C sub I, ith row, j, jth column in the output matrix is the sum from 1 to n, where remember n is the inner dimension of these matrices, of the product of A sub ir and B sub rj. So r is the sort of position we are as we're going, as we multiply. And this will be a lot clearer as we do examples. And this is very important. While matrix multiplication is associative, meaning we can regroup it, so A times B times C for matrices equals B times C, then multiply that by A. So we can regroup. We can distribute, so A times B plus C equals AB plus AC. But we cannot commute. We cannot reorder. So A times B does not equal, or is not equivalent to, B times A. And this is very easy to see, because what if A was a 3 by 2 matrix and B was a 2 by 2 matrix? Well, we can multiply A by B because these dimensions match. But we can't multiply B by A because the 2 and the 3 don't match. So we can't even start to multiply. And if we did, we could multiply, say it was a 2 by 3, we won't get the same result. So it's not commutative. So can a 2 by 3 matrix be multiplied by a 2 by 3 matrix? The answer is no, because these dimensions do not match. What about a 2 by 3 by a 3 by 1? These dimensions match, so the answer is yes. What about a 2 by 3 by a 3 by 2? 3's match, so the answer is yes. And what about multiplying these in the other order? We wouldn't get the same result, but we could do a 3 by 2 by a 2 by 3 as well. Okay? Wouldn't be the same result, but we can actually do it. Whereas with this one we couldn't, because you'd have a 1 and a 2. It wouldn't be the same. Now let's do a practice multiplication. We're going to find z, or z is x times y. So z equals, here's where we'll write our answer. Now, I'm going to use some colors here to help us keep track of what's going on. So the first entry in z is going to be the first row of x and the first column of y. That's how we're going to find it. So we have 2 times 3, that's 6. 1 times negative 1 is minus 1. 4 times 2 is 8. Okay, so 6 minus 1 is 5 plus 8, 13. goes is the first entry in the matrix that we multiply. So we'll choose a different color. Next entry, the first row, is going to be the first row, which was in green. Okay, so it'll be this first row and the second column. Okay, so we'll have 2 times 1 is 2, 1 and 1 is 1, negative 1 and 4 is negative 4. 2 plus 1 is 3, 3 minus 4 is minus 1. So we'll get minus 1 in this entry for z. The next entry would be the 1, 3 entry, first row, third column. So again, we take the first row and the third column. So we would have 2 times 2 is 4, 1 times 2 is 2, 4 times 3, 12. 12 plus 2 is 14, plus 4 is 18, so 18 is the next, is this entry, the first row, third column entry. Yellow's too hard to see. Let's go with red. So here we have the second row and the first column. So we would have 3 times 3 is 9. Minus 1 times minus 1 is plus 1, and 2 times 2 is 4. It gives us 14. Second row, second column. Second row, second column. We have 3 times 1 is 3. Negative 1 times 1 is negative 1. 2 times negative 1 is negative 2. 3 minus 1 minus 2 is 0. Second row, third column. Take the second row, third column of y. We have 3 times 3 is 6. Sorry, 3 times 2 is 6. Negative 1 times 2 is negative 2. 2 times 3 is 6. So we have 6 minus 2 plus 6. That would be 4 plus 6 is 10. Next would be we would do the third row, first column. So third row, first column. So here we have 0 times 3. I'm not going to bother writing that one. 2 times negative 1 is negative 2, because it's just 0. Negative 3 times 2 is minus 6. Minus 2 minus 6 is minus 8. Getting close to being done with this multiplication. We're running out of colors. Let's do one in black. So we have the third row, second column. So we have, again, 0. So 2 times 1 is 2. Negative 3 times negative 1 is plus 3. End up with 5. And then last but not least, I guess we'll just try yellow, even though it's hard to see. We would have the third and the third. So third row, third column. That gives us 0 times 2 is 0, 2 times 2 is 4, and negative 3 times 3 is minus 9. 4 minus 9 is minus 13. Did something too fast there. 2. 2 times 2 is 4. Minus 3 times 3 is minus 9. 4 minus 9 is not minus 13, it's positive 4. 4 minus 9 is minus 5. So the answer here is not minus 13, but minus 5. So that's how we do matrix multiplication. Let's do an example where we have word problem going with it. So 3 contractors are approached for bids for the renovation work that we described in the previous set of slides. Their hourly rates are given by R, with each contractor's rates in the columns. So this would be contractor 1, contractor 2, contractor 3. And the trades are in the rows. So you have the carpentry, electrical, plumbing. Okay, and here you have carpentry, electrical, plumbing, and we have the plan A, plan B. Okay, and so we'll end up multiplying, as we multiply 200 by 55, so 200 is the hours of carpentry by $55 an hour for this carpenter. For contractor 1, we'll end up with a matrix when we multiply that has the plans in the rows and the contractors in the columns. And we'll be getting rid of the trade information. So we're going to find this cost matrix C. First of all, when we multiply W, which is a 2 by 3 matrix, by R, which is a 3 by 3 matrix, what kind of matrix will we get out? The 3's match, we should get a 2 by 3 matrix. So first, let's find this cost matrix. So we need to multiply 200. We need to multiply first row, first column to get the first entry. And these multiplications are going to be a lot of numbers. So let's use a calculator to do this. So we have 200 times 55 plus 120 times 80, doing the first row and the first column of R, first row of W, plus 80 times 85 gives us 27,400 for our first entry in C. 27,400. Next one, we need to do 200 times 70, second column, first row of W, second column of R. 120 times 90 plus 80 times 110, 33,600 for our next entry. So this will be, of course, contractor 1, 2, 3, and plan A in the row 1 and plan B in row 2. So getting C13, we would have first row of W 200 and third column of R 60 plus 120 0 times 100 plus 80 times 100, 32,000 even. Now we go in the second row of W, first column of R, 80 times 80 plus 60 times 85, 26,680. But I think I made a typo. Let's look. 275, 55. Yeah, see, I typed 276. Simple typo. Let's fix that. 26,625. 26,625. Now we take second row W, second column R, 80 times 90 plus 60 times 110, 33,050. And last but not least, the second row of W, third column of R, 275 times 60 plus 80 times 100 plus 60 times 100 gives us 30,500 for the last entry in our cost matrix. So how much would it cost for the second contractor to build plan A? Second contractor plan A is C12, which is $33,600. How much would it cost for the third contractor to build plan B? Plan B is row 2, Third contractor is column 3, $30,500. So here's our answers. A large company consists of 2 divisions, and each division has 3 departments. The number of employees is given by the matrix E. The company goes through a restructuring, merging the 3 departments into just 2 departments. The structure is given by G, so what we want is E times F. E is our employee matrix, so here's our divisions in the rows, and our departments in the columns. Here's the number of employees in each department for each division. We're going to multiply this by this restructuring ratio. Notice that the rows all sum to 1 of this matrix. And then we'll find G, and we're going to use that to describe the new company. So G is going to equal, what will we get? So we have a 2 by 3 being multiplied by a 3 by 2. The result matrix will be 2 by 2. The 3's match. We're left with these 2 dimensions. So we'll just have 4 entries in G. Let's make space for the big numbers, though. So to find G11, we need to find first row times first column, 200 times 0.6 plus 300 times 0.3 plus 100 times 0.1. That gives us 220. First row, second column, 200 times 0.4 plus 300 times 0.7 plus 100 times 0.9, 380. $400 times 0.6 plus 200 times 0.3 plus 200 times 0.1, 320. And last but not least, 400 times 0.4 plus 200 times 0.7 plus 200 times 0.9 gives us 480. So you'll notice the number of divisions is the same and the number of people in the divisions is the same, but now the departments are different. So this shows us that the new company has the same divisions but each now has 2 departments with a mix of the people from each department, each of the old departments.